Welcome to the last session of the day. Really appreciate you all coming out to the summit. Hopefully you learned a little bit something. Hopefully you made at least one new friend. But today we're super excited to share with you the highlights of our next generation confidential AI platform. Before we do that, we'll share a little bit about kind of the big problem that we're solving to motivate why we are actually building this problem, or why we're building this platform. So what we've been seeing really is that a lot of AI projects, especially in the large enterprise, have been blocked for a number of different reasons, but we've simplified it down to kind of three primary reasons here. The first reason is that data is fragmented across a multiplicity of silos. What this means is that it's very difficult to actually operationalize any of your data because it just exists in so many different places. There's various access controls around your data, and in general, using that data is very tedious, very cumbersome. What we've also been seeing is that as the regulations have kind of picked up, as internal policies have become more strict, the regulatory FUD and the legal FUD in the space has continued to grow. What this means is that legal teams are preventing data scientists, data users from actually leveraging that data. Data owners are also very concerned about how their data is being used. So there's a lot of friction in that data approval process in the enterprise. And thirdly, we've also been seeing that existing techniques to try to make data pipelines more private, such as anonymization, tokenization, scrubbing, are they're very error prone, they're very meticulous, they're very cost intensive, very compute intensive, and overall they just add a lot of time to these projects. And the result of all of these three factors together results in a significant delay in the time it takes for these projects to actually reach production, and also causes the costs of the projects to balloon. So what are we doing here at Opaque to solve this problem? In a nutshell, we enable cloud scale analytics and AI on siloed confidential data with verifiable privacy. And what we've seen is that this has led to reduced costs, faster time to value, and lower risks. And additionally, our platform and our products can actually plug into your existing data stack and data infra, which enables you to extend what you're currently doing and build a confidential data pipeline with a hardware root of trust. So for example here, we're plugging our platform right into the LLM pipeline of both ServiceNow as well as a large performance auto manufacturing company that's based out of Europe to protect the proprietary data post-RAG. And in these cases, both companies are wanting to take advantage of many of the benefits that a third-party LLM like Azure OpenAI offers them without actually sharing a lot of their proprietary or any of their proprietary or confidential data with these third-party vendors. And with Opaque, they're able to do this. They're able to preserve the privacy of their data while leveraging a lot of the benefits that using these third-party tools provides. So here we'll talk a little bit more, or we'll talk a little bit about kind of the highlights of our next generation platform. On the functional side, we have completely reimagined how we manage data on the platform. What we've been hearing is that our CDOs, our CISOs, our CIOs are not having a very good time governing and managing all the data that is operating or that's sitting across all of these silos. So our reimagined data management has helped streamline governance for them. Our platform also offers more flexible, powerful, and portable workloads. So what this means is that our customers are now able to take their existing machine learning workloads, their existing analytics workloads, and easily kind of port that into the platform without having to change any of the tools, any of the frameworks, any of the libraries that they're very used to already using. And lastly, we now offer native support for a Python runtime. So what this means is that we're now bringing our confidential computing-enabled technology much closer to the language that the everyday data scientist uses. On the security side, we have taken network communication to the next level. So in addition to just normal TLS, we have upgraded our network communication to something called ATLS, which has been mentioned a couple of times already throughout the summit. But the basic idea is that in addition to authenticating not only the process on the server, you're now able to authenticate the hardware backing the server, as well as the the hardware backing the server, as well as the code that is actually running on the server. And lastly, we are now offering a cryptographically verifiable audit trail. So what we've been hearing is that data owners care not only about ensuring that their data is private, but they also very, very much care about seeing how their data is being used and also ensuring kind of control on that. So the cryptographically verifiable audit trail, which we'll show in the product tour that we're doing soon, enables them to ensure that the data is only being operated on in a way that they consent to. So before we dive into the product tour, this is a high-level kind of overview of our tech stack. So at the bottom here, we have the chips, the hardware that all of us love here at CC Summit, Intel, AMD, NVIDIA, and so on. On top of that, we are leveraging the Confidential Containers project. So this is a CNCF project. We call it Coco internally. I think it's nicknamed Coco, that offers kind of containerized workloads and provides an abstraction layer on top of the TEEs. So on top of that, this is where we are introducing, or where we have introduced, our proprietary technology. On the left here, you can see we have, as I mentioned earlier, the opaque ATLS service mesh. So what this means is that, as I mentioned earlier, the communication is not only encrypted, but now the communication is also attested. At the same level, we have what we're calling the opaque operator. So this is a proprietary Kubernetes operator that we've built that enables us to secure workload orchestration. On top of this, we have the opaque confidential runtime. And what this means is that you are now able to leverage a lot of the popular frameworks and languages for AI, like Python, like Spark, and run it straight out of the box in opaque. On top of this, we have the opaque policy engine, which performs cryptographic verification and also performs some other cryptography to ensure that in the multi-party scenario, so in a scenario where data is siloed, you need to kind of operationalize all the data together, that there are policies cryptographically enforced to enforce and dictate what is actually allowed to be run on all of that data together. And at the very top, we have our opaque jobs library, as well as the opaque job engine. So one of our missions here at Opaque is to make confidential computing accessible. My personal experience, confidential computing, the libraries, the tools are not the most fun to work with. So what we have at the top here is we provide a no-code user experience, and we also provide a notebook experience that you can integrate with the tools, the APIs, et cetera, that you know and love, such that you no longer need a cryptography specialist. You don't need a security specialist to actually leverage and take advantage of a lot of the guarantees that confidential computing provides. And on top of all this, as I mentioned, I think a slide ago, we provide a verifiable audit trail. This is completely enabled by confidential computing and the hardware root of trust. And again, the audit trail provides cryptographic assurance that data is only used in ways that you consent to. So with that, we will jump into the product tour. And in this product tour, we'll show you how enterprises can unlock the value of their confidential data to get rich insights securely, quickly, and easily. Okay, let me blow this up a little bit. Hopefully we can see that in the back. Yeah, so as I mentioned in this product tour, we'll show you how our customers are currently leveraging the Opaque platform to operationalize their data in a very accessible, very efficient, very cost-effective way. The first thing that you would do on the Opaque platform is join an organization. So you can think of organizations as similar to that concept on GitHub or on Azure, if you're familiar with those tools. But the idea is an organization enables shared work with your colleagues, the teammates that you know and talk to every day. So you can see here we have one organization with one member right now. The member's name is Alice. The organization's name is Cabrillo. And Alice has invited Deb and Kat to join her organization. To operationalize your proprietary or confidential data, you will need to share access to that confidential data to the Opaque platform. So a little bit on how this process works. The data is encrypted at source using a little opaque agent, and the data is then shared with the Opaque platform. By default, all encrypted data is shared with an organization, but this can also be configured. During the access sharing process, the user of the platform can define a description of exactly what fields or attributes they want shared with the platform. So in this case, for example, Alice has defined these particular fields to be shared, and we offer actually a kind of a clickable UI for you to define exactly what fields and attributes you want to share. And what we've seen is that this simple UI has actually saved our customers up to 10 months of work, because they no longer need to bring in another team to perform the anonymization, the scrubbing, and that whole process. So on the Opaque platform, once you have shared access to a dataset with the platform itself, the next thing that you would do is you may want to collaborate with other organizations. And this is done on the platform via workspaces. So for this product tour, we have created one workspace called Financial Forensics. And you can see here that we have Alice, again from the organization Cabrillo. And here we also have Bob from the organization Atlantis. And let's assume for this product tour that Alice and Bob want to share their data to achieve certain outcomes that we'll get into a little bit. So in order for Alice and Bob to share their data, they must share access to their respective data sets into the workspace. What this means, though, is that the data will remain encrypted even though it's shared with the workspace, and the data will remain encrypted at all times throughout the lifecycle of the computation, even during execution or collaboration in the workspace. And similar to the mechanism that we use to share access to data to an organization level, we can do the same thing in a workspace. So what this means is that, in this example, Alice and Bob can also define a subset of the fields and attributes that they want to share with a workspace, and this mechanism also has saved our customers a tremendous amount of time. So that is a little bit on the data, the data management process, the governance process. What we'll show next are jobs. So jobs are the mechanism on the Opaque platform via which you can actually operationalize your data. Jobs are they're executed on a confidential computing enabled runtime. So this is the Opaque Confidential runtime that we mentioned earlier. And jobs are completely verified, they are audited, and everything about a job must be cryptographically consented to. So for this, we'll walk through a couple jobs. The first job that we'll walk through is KYC analytics. KYC stands for Know Your Customer. We've seen Know Your Customer as a very common use case across a number of different verticals. For example, in financial services, one of our customers is actually performing KYC to do identity verification. And they're doing this in particular to prevent double dipping of sign-up bonuses. Another example of Know Your Customer is in the advertising, the marketing space. In this case, they are doing Know Your Customer so that they can identify which customers to upsell or cross-sell products to. So we'll walk through the job a little bit here, but as you can see, the job is written in Python. It's running on top of PySpark. And the API here that you see is identical to that API that you would use in a vanilla or an insecure Python runtime. Before we move on to the next job, I'd like to highlight this little window that we have here as well. So this is a visualized instance of our cryptographic policy engine at work. And if you can see the text, what we're showing here is that both Alice and Bob had to approve the job before it could actually be run. And this approval and this agreement is cryptographically enforced by the policy engine to ensure that your data can only be used if you grant explicit consent. The next job that we'll show here is a machine learning training job. So we're also working with some of our customers to do fraud detection. What we've heard from them is that obviously the more data you have, the more powerful your fraud detection algorithms are. So in this case, you can imagine that Alice and Bob are pooling their data together to train a machine learning model. And now you may ask, why is there an error here? What we've actually seen, and this kind of maps well to kind of one of the use cases that we're working on right now, is that we've seen one particular partner in the workspace collaboration be responsible for the training. So this partner might actually be, have some specialty in machine learning training that enables them to kind of be the best candidate for training. And the other workspace collaborators will license their data to the machine learning trainer such that the machine learning trainer can train the most robust and the most powerful model. What this means, though, is that the model is the machine learning trainer's IP, and as a result of that, the other partners in the collaboration should not get access to the model weights or the serialized model of the machine learning trainer. So in this scenario, what we're assuming is that Alice is one of the people that is licensing her data, and Bob is actually the one that is training the model. And as a result, because we're looking at Alice's screen here, she cannot see the model that is the resulting output of this job. This next job is where Alice actually uses the model that she has trained with Bob. So in this case, Alice is trying to do some inference. She, similar to the other jobs, has written some Python running on PySpark to perform some inference on some of the data that she has. And in this case, Bob has agreed to allow his model to be used for inference. And we can see here there are some results on kind of the accuracy of the model for Alice's test data set. Before we wrap up jobs, I also want to show you what we're calling the guided analysis. So the previous couple jobs that we took a look at involved writing code. And again, one of the missions of us here at Opaque is to make confidential computing as accessible as possible to the everyday user. And what we've heard is that this no-code user interface really helps with that. Now, you don't even need to have an engineer or a data scientist that knows how to write code to leverage confidential computing and get business insights. Instead, you can have a business analyst that may not be as familiar with code, click a couple buttons in the UI, and they're now able to run similar jobs as you would with the notebook interface. Before we wrap up the product tour, we'll highlight one last feature. So you heard me talk a little bit about the audit logs in a couple slides earlier. So as I mentioned before, what we've heard is that data owners care not only about the privacy of their data, but they also care a lot about the way that their data is used, and they want proof that the data was used only in ways that they allow. So here what we're showing is that we have an audit log, but not just a normal audit log. In our case, the audit log is, each record in the audit log is cryptographically signed with a hardware root of trust, and the data owner in this case can actually verify via some cryptography that the data was used in ways or in certain ways. So that is it for the product tour. Let me jump back to my slides. So yeah, in this product tour, we showed you how Opaque empowers you to securely, quickly, and easily operationalize your data to unblock AI projects, and specifically in the case of data silos. And we've heard that with Opaque, our customers have gotten 4 to 5x faster time to value, increased flexibility, significant cost savings, and reduced risk. And one last plug before I leave. We recently released or are kind of preparing the AI Confidential newsletter. This is a newsletter by the community, for the community. We encourage everybody that has something to say about confidential computing to share their thoughts. Please reach out to me if you want to kind of be featured in this newsletter. We'll ensure that your content is distributed in the way that it deserves. So that's it for me. Thanks so much. Thanks for coming to the summit once again.